Tenths become decimals. Hundredths become decimals. Place them on paths.
Welcome to the Meadow Garden. Here, Kit the wise math Sheba watches over Pip the chipmunk as he meticulously plants morning seeds. Normally, if you want to track exactly how many seeds are in the ground, you write a fraction. You have to stack a numerator on top of a denominator. But when you plant in specific groups of 10 or 100, writing two stacked numbers for every section of the garden takes unnecessary time. Pip needs a faster way to record his crop. This graphic of a 10-hole soil strip shows the solution. When a fraction has 10 or 100 on the bottom, you can write the exact same physical amount using a shorter label, a decimal. Watch Pip on the macro scale. He moves step by step along a single furrow of soil, dropping one seed each into 3 specific holes. This vector illustration shows how the math handles this space. The strip is divided into exactly 10 equal holes, making the bottom number 10. Each hole is 1/10. Now Pip planted 3 specific holes. The top number is 3, creating the fraction 3/10. To write this as a decimal, we look directly to the first place after the dot. That space is the tenths place, so 3/10 is written as 0.3. That single digit immediately following the decimal point exclusively measures how many tenths of a hole we have. Now Pip scales up to a large garden plot. He rapidly plants 6 full rows of 10, plus 2 extra holes. This overhead diagram shows a much larger grid. With 100 equal holes in the bed, each hole represents 100th, setting the bottom number to 100. Pip filled 60 holes across the full rows, plus 2 extra, giving us the fraction 62 hundredths. In decimal shorthand, the second place after the point is the space that counts hundredths. We write this total amount as 0.62. To accurately represent a hundredth, you absolutely must use 2 digits after the decimal point. Let's see what happens when Pip completely fills exactly 3 whole rows of that large 100-hole bed. That generates the fraction 30 hundredths, or 0.30. This layout shows what happens if we physically slide Pip's original 3 out of 10 strip directly alongside the 30 out of 100 bed. The shaded lengths match perfectly. If you multiply the top and bottom of 3/10 by 10, the mathematical result is 30 hundredths. Because the identical amount of physical soil is covered in both plots, 0.3 and 0.30 are mathematically equal. This diagram of a garden path maps the same base 10 logic onto linear distance, stretching from a starting point of 0 to 1. Because the total distance is divided by 10 stepping stones, each stone represents exactly 1/10 of the path. Pip hops forward along the path from 0 and comes to a complete stop directly on the 7th stone. By stopping on the 7th step out of 10, Pip has covered 7/10 of the path. This physical distance proves that 0.7 equals exactly 7/10 in linear space. Look across the meadow garden. The physical proofs are everywhere you look. 0.3 in the strip, 0.62 and 0.30 in the large plots, and 0.7 on the path. The rule holds firm. A denominator of 10 means tenths. A denominator of 100 means hundredths. The decimal is simply the shorthand. With the seeds planted and the distances measured, Pip finishes his work, and Kit the Sheba trots off into the meadow. Decimals are not a new abstract species of number. They are simply a specialized label built to reflect the exact physical reality of base 10 fractions.
3/10 is 0.3, 62 hundredths. Decimals name fractions.